Hello, everyone. I hope you had a good break. We are back now in the two different tracks. And for this track, we will be opening as a follow-up of the topics we were already covering yesterday, but we'll continue to a higher level with a talk from Valliappan Narayanan, which is unlocking the power of LLM, harnessing the potential of an API gateway for large language models. Hello, Valliappan. How are you?
Good. How are you? Hi, everyone.
I'm doing well. Thank you very much. You told me you have a lot to cover, so I'll let you maximum time for that. Thank you.
Awesome. Can I start presenting?
Yes.
Okay, cool. Do you all see my screen?
Yes, we see your screen. Everything is good.
Awesome. Yeah. As Maidi mentioned, I'm Valli. I'm engineering lead at AT&T. So I think large language models has been the talk of the town recent days, and we all kind of use GPT or some other models and directly use their APIs. But today I'm gonna cover from the enterprise standpoint. So what are the guardrails and what are the gateways that you have to put on top of the existing APIs like OpenAI APIs in order to power the large language models to your enterprise use cases. So when you have multiple teams in your organization working on different use cases, at some point you want to build the API on top of the existing large language models. Either it could be Azure or it could be OpenAI directly to take care of some of the things which we're going to talk about in the rest of the presentation. Okay, so why do we need an API gateway and what are its benefits? So we need API gateway for a few reasons, as you can see. So I just quickly go over. We are going to talk about this in detail, but I'll just quickly go over why do we need an API gateway? So so API gateway is actually a stack that helps with orchestrating with different APIs and write security performance on top of it to maximize the potential of the API. And some of the things that we're going to discuss and why we need API gateways are some of the security reasons, performance optimizations, cost optimization, error handling, monitoring, and how do we integrate with different systems? How do LLM APIs integrate with different systems? And how can we incorporate some of the ethical and responsible strategies of the organization with that gateway? So with that, I'll go into the first one, the security considerations. So definitely security is one of the top priorities when we try to use a technology like this, especially a new technology like this, and when we have a lot of talks around going on LLMs like hallucinations, etc. So security is a top priority. So our job is actually to protect against the malicious users, like data privacy, etc. So one of the things that you could do in your API gateway is implement authentication and authorization mechanisms in order to give access to who can access the APIs and who can access the LLMs and how they can access it. And you can also incorporate things like compliance and some of the governance, like the compliance and governance your compliance and governance teams comes up with. You can incorporate those things in your API gateway so that gets propagated to all of the use cases. So you implement these security, compliance, governance in one place, which can be utilized by everyone in the company when they use your API gateway. And definitely you can put put considerations around intellectual property rights and then privacy, etc. So those all can be incorporated. It can also be a centralized point for the client requests, and then allowing for consistent access, and then security policies can also be incorporated here. So that's one of the good things about having an API gateway on top of the LLM APIs. So the next one is the performance optimization. This is also a very important one, actually, when developing against the LLMs or the API gateway. So we could have a caching mechanisms for frequently used requests, especially when you are doing search, semantic search, you could use some caching mechanisms so that you don't go to the source all the time. And then you could do things like request batching, and then response caching, load balancing, etc. So those are some of the things that you could do in your API gateway on top of the LLM. And then you could distribute requests to multiple instances, like the usual load balancing, whatever you do with the traditional applications. This helps in this mainly helps in maintaining responsiveness and scalability, even through the times of high traffic and increased demand. So the next one that we're going to talk about is actually cost optimization. So it's one of the important topics, right? So we all know LLMs are very expensive. So it's definitely important to stay in the budget, etc. So some of the things that I have seen it working is using multiple models, not just the most expensive model. For example, if you're using GPT, OpenAI has multiple models, not just DaVinci, the most expensive one, they have other ones. So you could use different models for different use cases. For example, for certain use cases, I have been using the least expensive model. But for other use cases, important use cases, I've been using most expensive model. So I choose the model based on the use case and its importance. So you could configure all this in your API gateway, saying probably for summarization, you could use least expensive models, but for customer support, you could use most expensive models, etc. So the next one is this is one of the important things on any API gateway, not just API gateways on top of LLMs, like error handling and resilience. We should define a proper error codes, retry mechanisms, circuit breaker mechanisms, and fault tolerance to ensure we have a very good robustness. And then we have very good reliability in terms of when there is a potential failures or disruptions. So the good thing about it is, let's say if you have multiple teams in your organization working on different use cases, you could incorporate all this logic in the API gateway, which serves as the gate for all these use cases. So all of them will get benefited if you incorporate what the things that we are talking about, like the security, the performance, the cost optimization, the error handling. So that every team doesn't have to go through all this, and they have enough freedom and peace of mind to actually work on the actual use case and not work on things like error handling, resilience, etc. So that's I think we are at the halfway point, but I hope it has given you some idea about why do we need an API gateway and what are some of its benefits. But there are a few more things that explains why do we need an API gateway as well, which we're going to cover. So another most important point is the monitoring, right? So if there are different teams in an organization working on use cases, at some point they want to monitor how is it performing, are the answers right, how are we doing in terms of hallucination, misinformation, etc. So the idea is to actually implement monitoring in one place, that is in the API gateway, where the teams can come and utilize it. I'll give an example. So one of the things that worked for me in the past is we used Power BI actually to visualize how many requests a particular use case is making, what are its response times, what are its token size, etc. So we group the projects by the use cases, and then every use case when I say use case, every team have their own implementation of LLM and why they use it. So they can go and visualize how much calls are they making, how many failures, success, tokens are they utilizing, what models are they utilizing. So it can be not just a Power BI, it can be connected to any visualization tools like Google Studio, things like that. So they get a nice view of how are they performing, where they are lacking, what are some of the optimizations that they could do, and then how they do a better resource utilization, etc. And we could definitely do some analytics on top of it, and then it helps in the overall system performance and the reliability. And then it also helps organizations to track the usage, and then it helps with cost optimization as well. So the next one is actually, it's also one of the important topics when we use LLMs, the ethical and ethics and the responsibility. So like the organizations has different teams like legal, privacy. They have their own way of how the things should look like, how the brand should look like. Are we giving the right responses? Like, are we staying within the limits, etc.? So you could incorporate all this ethical considerations into the API gateway that get propagated to all the use cases in your organization, or if you have multiple use cases. And then the other thing that you could do is actually like bias mitigation. Like if there is any bias in the model, you could actually do all that in the API gateway. Again, that gets propagated to all the use cases. Like the fairness, I mean the transparency of it, you could visualize how the responses actually derived from, and the what data is being used for training, etc. So this is basically to be more responsible, like having the responsibility of using the model, like technology like this, and then also to avoid potential negative impacts on any individuals or communities. So, I mean, I highly suggest we incorporate some of these into the API gateway so it can be useful for anyone who is actually using it. And the next one is the integration of the existing system. So in your organization, like there could be multiple systems, and we have this new system that is LLM. So we also need to worry about how are we gonna integrate this LLM with other systems, like how the data gonna look like, the compatibility of the data, the how it's gonna synchronize, how are we gonna version it, and then like how are we going to maintain the system's integrity. So like the data flow getting into like your ETL or your data storage, etc., or data lake. So we also have to think about how do we integrate with other systems, and implementing these things at the API gateway can be helpful so that the use cases, the people who are working on use cases doesn't have to really focus on doing this. Rather, the API gateway, if there's a separate team for API gateway, can work on this. The application team, the product teams can actually utilize that. So that's the end of like the different needs and the benefits of the API gateway when using an LLM. But the point is actually, you may not need this API gateway if you are just implementing one use case, and that's all you're gonna do in the future, because you will be incorporating this API gateway into your stack automatically. But if you have multiple use cases in your organization, then it is a good idea to implement an API gateway so that all of these things that we have discussed, the 7 things that we have discussed, can be bundled and implemented on this gateway that can be utilized by others. I mean, that's the end of it, but I'm happy to jump into any particular topic or questions.
Yeah, thank you very much, Valliappan. So one question about security. You know, yesterday we had some people from the OWASP LLM security, who are talking about like prompt injection, or all these new security, let's say, or hallucination injection or stuff like that. Like, how today is it on the API gateway level that you should consider these new security layers?
Yes, I think it would be very beneficial if you implement this at the API gateway level, right? So imagine if you are working on multiple use cases. So if the gateway team can implement this, the platform team can implement this, everybody can inherit this actually. So highly suggest to implement this at the API gateway level.
There's also a question about the rate limiting. That because actually 2 questions on rate limiting. The first one is mostly about the fact that the LLM may be used by your own end users who would prefer the LLM integration or ChatGPT plugin or whatever LLM plugin versus getting to your APIs directly. So how should you consider authorization or rate limit counting when the LLM is actually a proxy for your own users to consume your APIs?
Sure. So I would start simple, like using the traditional rate limiting, and don't get too fancy about it. And then like you can queue request to start with, and then yeah, I mean the traditional rate limiting would work actually.
Okay, there's a question about temperature. LLM, just for everyone, but LLM can, when they generate text or pictures or content, you can have a temperature between 0 to 1, and the higher temperature is, the more you allow to generate things, and so maybe to have to be more creative. But so the question is mostly when you imagine like government authorities APIs, or like a trusted source of information. Do you know any possibility to limit the usage by too high temperature LLMs? Say only if the prompt is temperature below, I don't know, 0.3, I allow the request to pass. Do you know anything like that, or it's not implemented yet?
No, certainly you can do that, but it really depends on the use case. I'll give you an example. So if the use case is around content creation, like a blog content creation, you have to be more creative, right? The temperature has to be like probably more than 0.5. But if the use case is like customer service, right? So you don't want to be creative in customer service. You have to present the facts. So you have to limit that to like 0.2 or something like that. So I would leave that responsibility to the person who actually is responsible for the use case, but not by the API gateway team actually, right? Like
Okay.
they should have a responsibility of what temperature they want to set to get better results because it's their use case.
So like a temperature access management, like or something like
Yeah,
that, but like,
yeah,
yeah, I don't
uh,
know, just
yeah. But you could limit the temperature. Nobody's going to stop you because you are the one having a gateway before the request reaches LLM. You could limit, but I seriously doubt like whoever is creating the use case has to really aware of that and control that. Not really like having the LLM put the guardrails around like don't go above 0.5 or things like that. But you could do that like in API gateway, set the temperature or to limit the temperature.
we have a question about the open source aspect. Today, do you consider all open source gateways can actually be a good fit for LLM, or there are only a small selection of them?
Sure. I mean, we have developed our own gateway. Like, we haven't found any gateway that really works with the LLM use cases. Maybe it's too early. We haven't seen that. Uh, but definitely, I think taking the existing open source gateway could be a good place to start, actually. Yeah. Like, especially with rate limiting authorization. Yeah, any rate limiting open source would work.
Yeah, perfect. Thank you very much, Valliappan. This is all the question we had. Thank you very much. And again, we'd love to have you maybe in an in-person conference in the Bay Area or in New York area when we go there.
Awesome. Great. Thank you, everyone.
Thank you. Have a good one. Thank you very much. So we're a little bit early, but we can already start with our next speaker, right? Baljeet Malhotra. Hello,
Hi,
Baljeet.
Mani. How are you?
Doing well, doing well. I remember our discussion of, about time of services and APIs and how we can try to solve, let's say, this problem, as a business risk from legal agreements. And it seems you made a talk about it.
Yes, absolutely. So let me share my screen.
Yeah, and also just to let you know, you have a little bit more minutes because of the audio speaker went a little bit shorter. So yeah, you can take a little bit of your time.
Okay, I just uploaded my PPT. So is this the PDF version or the PPT?
At least we see it full screen. I don't know what it is, but it works.
Okay, great. So let me see if I can.
Are you moving the slide? If you're, yeah, okay. Now we see a second slide with
Okay.
all your, yeah, it's moving.
Okay,
Perfect.
so let me I had looks like this is the PDF version. Let me try uploading the PPT. Just give me 1 second.
Perfect. This is why we have extra time too.
Okay, looks like it has uploaded.
Or you can share your screen also, right?
Okay, it's almost done.
Seems to work.
Okay, great. So let's get started.
Perfect.
Thank you so much for the opportunity to be with the audience today. Good morning, good afternoon, wherever you guys are. My name is Baljeet. I'm the founder and CEO of TeejLab. You can read more about me on my LinkedIn and professional other networks and resources. So let me talk about first how or what are the best ways to quantify today's API economy. And one way we thought we can quantify this API economy is comparing the growth of APIs with the growth of websites. So, web services, websites. And philosophically, it makes sense to compare because at the end of the day, APIs are transacting data. They provide information very much similar to websites. It's just that APIs are a bit more dynamic. They provide more machine-to-machine automation, perhaps more intelligence with some AI ML-driven solutions. So if you look at the blue curve, so this is the growth of the websites, and this other curve represents the growth of APIs. They are not at the same scale, but they're expected to grow to the same scale with software, data, services moving into the cloud. You will see more and more integrations which will be done through these APIs. As a matter of fact, if you look at the number on the right-hand side, 83%, that actually quantifies very concretely, the amount of data that is being transacted over the internet through these APIs. Now, why this slide was important for me to talk about the API legal agreement management was on the next slide. So if you look at some of the global repositories, either Postman or MuleSoft has, programmable web. Unfortunately, they shut it down, but that was one of the largest repositories out there, and Rapid API. So all these repositories were there that are kind of tracking these APIs at a global scale. And we as a company, we started tracking them back in 2019, and we have built a knowledge base where we can see these APIs, not only what are the endpoints, what data they are being transacting, but also the legal agreements that govern the usage of those APIs, which is the topic of this discussion today. So why we want to do this? There are several benefits of tracking these APIs for risk management to better govern the API economy, and to provide solutions to enterprises at global scale, and discovery, risk management, leveraging upon the existing infrastructure. Speaker before me talked about how gateways and models, machine learning models, are coming together to provide new kinds of services, access control mechanisms. And this continues to evolve. And having the ability to look at these APIs at a global scale gave us the ability to share some of the interesting insights that I'm going to present today. In order for us to quantify these risks, or as a matter of fact, any business problem you're trying to solve, you need metrics. API health, API category, API inventory. More recently, OWASP included API inventory or API discovery in their top 10 recommendations, because a lot of enterprises are actually struggling with their inventory, just managing their APIs, finding their APIs, where those APIs are, and finding the associated analytics. And on top of that, you need to understand their functionalities, if there are any vulnerabilities on those APIs, authentication, authorization issues, and there are a lot of other issues as well. Are they transacting any personal information, and so on and so forth. Some of the other metrics that I mentioned here, like trust, risk management, health, are a bit more difficult, but there are mathematical ways or model-driven approaches that we can apply to quantify these risks or monitor these APIs for various purposes. From a security point of view, from a risk management point of view, or even managing the compliance and compliance from a business point of view. Now, specifically, the topic, unfortunately, my animation is not working, but I was going to highlight the topic for today is the API agreements and what are the associated risks that we see by looking at these hundreds of thousands of APIs all across different geographies. Typically, in an enterprise environment, you might have seen, and Madhi, actually, you are one of the leaders in this space. You are looking into, how we can help as a community enterprises manage their legal agreements. There are automation solutions, but nonetheless, companies continue to adopt various frameworks to manage or govern their APIs. Privacy statements, privacy documents, global privacy statements, API terms of use, platform policies, and whatnot. Specifically, when these services, they evolve to become more complex, where it is not just the technology and the functionality that is being exposed through an API, but if the community is involved. For example, the platforms like Facebook, Uber, Airbnb, where a lot of APIs empower different businesses to operate on these platforms, these things could become very, very complex. And the difficulty is these vendors are constantly evolving their terms of services, their privacy statements, their usage policies. And we, as an API management company, since our task is to track these APIs at a global scale, tracking these agreements become even more difficult. As I mentioned on one of my slides, that we have over 50,000 or so APIs that we are tracking in our knowledge base. The licensing issues, security issues, compliance issues, data, what data they're exchanging, and so on and so forth. And if you do a simple math, if each of those APIs have at least 2 documents to govern their usage, privacy statements and the terms of usage, then you're talking about a factor of 2, 50,000 times 2, so 100,000. Now, this is just the beginning, how we are quantifying this API economy moving forward. And how do we make this economy more smarter by managing these legal agreements, perhaps leveraging upon some of the AI technologies that are available. But now you scale that and multiply that to hundreds of thousands, to perhaps billions in the future, and at least 2 times of that legal agreements that you need to track, that you need to manage, that you need to quantify the risk, and so on and so forth. So it's a really very interesting problem for us to solve. And today, I will not be able to talk about all those problems in one go, but I will definitely give you some glimpses and pieces of those problems. So let me start with some use cases. One of the challenges that you face when you have a very large API ecosystem, And I'm talking about large, in a typical enterprise, in hundreds of APIs. I've seen first-hand cases. Forget about the entire company. Forget about all the products and services. I'm talking about one single product with thousands of API integrations, at least 5,000 or so that we could count. And if you go back to my previous slide where I compared them with the growth of websites, um, the data governance, data sovereignty becomes truly a problem here, because your APIs may be hosted all across the globe. These are essentially transacting data. It's much easier for a DevOps team to move their servers from one location to another locations, and your URI never changes, so you never know. Now your data is being stored, even if it is a single sign-on API, just storing email address or some sort of identification that is personally attached to your corporate ID and whatnot. At the end of the day, personal information. So when you look at this ecosystem, it's not just about managing APIs from a product point of view, but also from a data governance perspective as well. And that makes it very interesting, because if you look at the laws of the land, I'm just giving a snapshot of the laws in the US. There are other sets of laws in Canada, in India, in some of the other countries as well. So many of these laws talk about protecting, consumers, protecting children, protecting, enterprises' business interest, and so on and so forth. And many times, those terms of services would refer to these laws of the lands, and you, as a consumer or producer of those APIs, and hence providing those legal agreements, it is your responsibility how this ecosystem evolves. Specifically, from a consumer point of view, if your enterprise ecosystem depends on a lot of third-party services that are integrated through these APIs, your challenges escalate greatly. And mining this data, looking at some of these issues becomes a very important problem, where machine learning or natural language processing or some of the other AI technologies can help us. And I'm going to show some of those use cases now. So one of the case studies we took was, let me rephrase again what I have covered so far. So we are tracking these APIs at a global scale into thousands, their legal agreements into hundreds of thousands, and in the future moving forward, perhaps millions and billions. And one of the things I even spoke to Madhi about this. If you remember, we talked about this. Having standardization is one thing, where we can collect some of the thought leaders and industry players together to standardize some of this. But perhaps you will tend to agree to me that unstructured way will still continue to evolve for various reasons, business reasons, laws of the land. So these companies will be forced to adopt various frameworks and whatnot. So we wanted to sample this data. So what are the terms of services provided by, Facebook, LinkedIn, OpenAPI, more so. And we found, now you can imagine, we cannot do this manually. We could certainly hire an army of people to start analyzing and taking help from our lawyer colleagues. But as you can imagine, this is not scalable, right? So we need machines help. We need artificial intelligence. We need some sort of natural language processing solutions. So we wanted to do this at a scale which represents the knowledge base that we have, tracking these into millions. And we took some samples. We may not have time to cover all of them, but as you can imagine, I'm highlighting some of these cases here. So in this particular case, with OpenAI, this is the hot topic, not just OpenAI, but a lot of AI-driven technologies where there are models and the vendors are providing different evolving terms of services, how they should be governed, how they should be used. So I'm highlighting one of this thing. You might, if you come from a compliance background, audit background, you might have heard of expression called export control. So whenever softwares are shipped, there are strict guidelines, and you have to be compliant with those laws that these products are not shipped to countries where there are restrictions. And OpenAI in this context is not very different. So they are talking about their services, in this case API integrations. They cannot be used in the context of where there are export embargoes. Now you go back to my previous statement. Now these are APIs. Of course, gateways can access control where the traffic is coming from, if it is coming from a different geography, but that there could be proxy solutions and whatnot. So it becomes a very difficult problem to enforce these constraints or these terms of services across your usage base, and monitoring, taking the behavior of those users and making sure that you are compliant with these laws. Of course, hackers and the malicious users will continue to defeat the purpose or defeat the system. But again, you got to do the best you can. So this sampling of these legal agreements and what kind of different approaches these enterprises are taking, or as a matter of fact, not just enterprises, government organizations, nonprofit, and everybody pretty much in the same API ecosystem, having the same challenge and issues. Another case study that I want to highlight here is of Facebook, and this is in particularly very interesting one. But let me take a quick pause here to see, Madhi, if there is any question from the audience. I don't mind being interrupted right now, and see if there is any question I can answer. Or Madhi, if you have any questions, I'm happy to answer right now, or I can simply continue. All right, so looks like okay, so looks like there are no questions, so I'll just continue. So in this case, one of the interesting things we observed with Facebook terms of services is as I mentioned, we could track how these are evolving, what kind of different strategies these enterprises are taking to govern their usage. So what I'm highlighting here on the screen is an assessment of which is done by, of course, by the AI, because we cannot just simply do this manually. Here, the assessment, the AI-driven assessment, highlighted that there were certain terms and conditions back in 2017 that actually made sense from Facebook's intellectual property perspective. For example, in this case, I'm highlighting Facebook is essentially saying, don't replicate core functionalities that compete with Facebook features and functions. And as you can imagine, this makes complete sense. I mean, why would any business would want to give you access to your APIs to build products and functionalities that compete with them, right? So that doesn't make sense from a business point of view. And we continue to investigate this, and there are some other terms of services where you can see don't build apps and so on and so forth, which restrict you or violate certain policies from laws of the land, or violates the policies of Facebook, or as a matter of fact any other enterprise. Interestingly, in the very recent terms of services, all of those constraints were dropped. Now, the question you may want to answer, or perhaps at least think about it, why an enterprise would do that? Why would they stop saying that, stop using my APIs to build the features that compete with me? Now, there is no straightforward answer, because we can only speculate. We don't know exactly what the strategy is. Perhaps could this be a technical mistake? But I would imagine this is not a technical mistake. Of course, they have a lawyer of armies. They have an army of lawyers, and they would be very, very due diligent, or as a matter of fact, any enterprise would be very due diligent to do this. Now, then the next thought comes into our mind is, could this be a strategy where you want to see how the competition evolves, and perhaps a strike at a time when this becomes challenging to you, right? So if you are too restrictive to begin with, and curb this acceleration of innovation which APIs bring to the economy, it becomes a very, very interesting problem. Now, this becomes a double-edged sword. It can swing both ways, right? So it could be counterproductive, but it could also be very effective enterprise strategy where you could essentially check some of the competition. Now, we may not necessarily have time to go through all those details, but I hope you get the point. I hope you get the point why API legal agreement management at a global scale, we as a company becomes very useful, but also for enterprises or enterprises that need to use third-party APIs to get the analytics that could be useful to mitigate their business risk that you can perhaps classify and quantify from these legal agreements. Now, so let me summarize, why this is challenging. First of all, moving forward, or as a matter of fact, right now, you may have thousands of APIs, hundreds of vendors, perhaps hundreds of tools all across your enterprise products and services. And not just I'm talking about API management tools. I'm talking about all your analytics, software scanning, security tools, your data warehouse tools, all kinds of tools. Pretty much every products and services are integrated through those APIs. So you have invisibility issues, you have scalability issues, which teams are using which APIs, and so on and so forth. So collectively, managing your legal agreements governing the usage of those APIs becomes a very interesting yet very challenging problem. So if we still have time, Madhi did mention that we have a little bit more time because the earlier presentation went a little bit faster. So Madhi, if we have maybe a few more minutes, maybe 1 or 2 minutes, I can give a quick agreement processing demonstration live. If not, then I'm ready to take the question.
Put me in. Yeah, you have the time. You have 3 minutes.
Okay, great. So I would like to give a quick demonstration of what I talked about. So Madhi, you can see my screen, a browser login page.
Yeah, login Canada.
Okay, great. So the use case I want to showcase is exactly what I described: Open API, Facebook, and perhaps Microsoft's terms of services. So of course, I'm going to ignore everything else, but I'm just going to walk you through some of these use cases. The other interesting aspect I will highlight is, for example, if you look at the terms of services here, another challenge is they could evolve. As I mentioned, they are living documents. They have to be evolved, and there is a reason behind it, because all these APIs usage are rooted in the usage of essentially data. And new laws may come, new policies, enterprise policies may come, so they must be evolved. So you can see that this Open AI terms of services just evolved back in March in 14. And if you look at some of their privacy terms, they evolved just in June this year, just a few days ago. And this is what I was talking about, and so is the case with every vendor, with every terms of services and whatnot. So let me show you the 2017 assessment of Facebook policy. So this is the AI solution that is essentially analyzing the terms of services or the platform policy of Facebook right now, where it will highlight some of the permissions, some of the obligations, some of the prohibitions, and whatnot. And as you can see that in this case, they are talking about don't replicate core functionalities of Facebook. That's in 2017. Now let me do the assessment of their today's copy. So this is today's. This will pick up the latest copy of Facebook platform policy and will analyze that. Now, interestingly, as you can see that no constraints found. So this is 2017 and this is 2023. Now, there are so many other interesting use cases we are discovering by mining, managing these agreements at a global scale, and we would not be able to do this without the help of artificial intelligence or natural language processing solutions. So I will stop sharing this screen and switch my screen to. So Madhu, you are seeing my screen again, the slides.
Can you put? Yes, we see API agreement management. Yes.
Okay, so I invite all my colleagues or the audience to check this out. We have a community platform, and we would love to get your feedback and see how we can solve this problem together. This is a massive issue, massive problem that will block the growth of API economy moving forward. So I'm Baljeet. This is my contact information. Very grateful to Madhi and the team and the rest of the API Days interface team for inviting us to talk about this problem. I'm very happy to stay for a few more minutes and answer any questions. So Madhi, thank you so much again. Back to you.
Thank you, Baljeet. One question I have is, in the supply chain and logistics industry, procurement teams actually knows well the contract, they knows well the delivery time, they know all these engagement, and actually this is their job to manage like hundreds of suppliers, conditions, deliveries, SLA at some point, but like physical SLAs, right? And most of the time they know how to do that. Why before your solution, right? But why today we did not have the same knowledge on the digital world, right? No, it's still the jungle, many API terms, privacy terms, term of services, and like enterprise agreements. Like it's a huge mess. Why we've not been able to kind of standardize or at least make it a real practice of digital risk supply chain management?
Yeah, that's a great question and also a thought at the same time. And there are several challenges, but let me highlight two important challenges. First of all, the difficulty is either you talk about SLAs or even open source. Open source had licenses, and the legal teams are very much familiar with the licenses, and they know how to mitigate those risks. The difficulty with API terms and privacy statements and the other legal documents that govern the usage of those APIs, they're always evolving. And now a typical enterprise is dealing with at least thousands of APIs. And you can multiply that with at least 2 times, so 10,000. So as a matter of fact, I spoke to a few of my lawyer colleagues who were responsible for the due diligence for third-party usage in a very large enterprise. And they said, Baljeet, we can't solve this problem, man. Every time a developer comes to me for an open source usage, I know how to guide them and say, okay, go ahead, you have the approval, go use this open source. But they say, I don't know what to do with the APIs because I do the approval today. They could change tomorrow. Should I go every 2 months? Should I go check them every 6 months? So the scalability is the issue, Madhi, here. The other difficulty is, now you pointed out another thing, why the legal agreement document management companies cannot solve this problem. The problem is it's so big and huge. And we need to apply new methodologies, new technologies like AI and all that to take the next step forward.
But on the API term of services, on the open source license, the open source initiative like 25 years ago said, okay, this is the definition of open source. Like we don't have yet the definition of an open API, but we have these licenses which are quite well standardized, like MIT license or Apache 2 license, or where everybody knows what's in there. Like it's at some point it's easy to understand. But with API term of services, every lawyer is doing their own terms. So do you know any standardization projects or anything like that to standardize API term of services to make them more easily readable?
Well, one is by you guys. So the last time I got familiar, you told me that this is an effort that you guys are taking. But to be honest with you, I did not see any effort in this context yet. And the reasons could be, see, APIs are very dynamic. One day you have an API that is exposing a JSON response containing one data, but that API may evolve to include some other pieces of information. Now the terms of services have changed, or should be changed, right? So like SPDX or some of the other organizations or efforts that have looked at this problem from standardization point of view. But to be honest, it's a very difficult problem because every enterprise has its own strategy. There are different geographical boundaries. There are export control policies. Then they have their own strategies, how they want to monetize it, the rate limits and all that stuff. So that makes this, it is still possible. I'm not saying that it is not possible to standardize it. But what I'm saying is, even though the standardizations will be adopted, but it is just a matter of time, those will evolve to have some use cases and edge cases that you will still need, AI-driven solutions to monitor, because you cannot simply go monitor them manually.
Yeah, I agree with you. And the API-TOS.org project we're running is actually, we found that there are too many degrees of liberty to standardize, but at least we can have some standard clause.
True.
So that at least 5 or 6 or 7 clause amongst like 40, but at least that are the important ones and that are clear and easy to understand. Then the other ones will be there. Yeah. Thank you very much, Baljeet. Thank you. Yeah, thank you, Baljeet, for your presentation and for explaining that in such a meaningful way.
Thank you so much, Madhi, for the invite.
And see you to the next APIs conference.
For sure.
So, yeah.
Sorry, you were going to ask something?
No, I was just saying really thank you for that and hope to see you in person soon.
Yeah, we will. Thank you so much, Madhi. Have a great day. Bye.
You too. Bye. And we continue this track with a talk about leveraging event streaming to supercharge your business solutions by Mari Grygleski, senior streaming developer advocate at DataStax.
Thank you.
Hello, Mari. How are you?
Hello, Mehdi. Good. How are you?
I'm doing really well. The goal of this track is really to show the latest trend. So
Sure.
LLMs or terms, supply chain risk management, and now event streaming. So let's go for that.
Sure. Thanks a lot, Mehdi. Thank you, everyone, for joining me today. I know we don't have too much time, so I'm going to get started. So my title is about leveraging event streaming to supercharge your business solutions. Now, I actually came from more of a developer background, so I tend to talk more, to the developers. So I'm hoping that, kind of bridge, like developers understanding and really maybe some of you are here to really search for solutions. How do you solve problems, right? And so I like to propose to event streaming is a kind of a must-have type of, kind of mechanical, if you kind of treat it like that, type of systems, and they're complex. And so I want to explain that to you. So let me then, before I start, right, if you like, slide deck, you can actually use this bit.ly link and connect to it and the QR code. I've also shared this with the organizer too, so I won't leave this on for too long, and I'll share this page with you again towards the end of this presentation. Even if you miss it, don't worry, we'll be able to share that with you. Okay, so really quick, I'm a developer advocate at DataStax. As you know, you may be aware, DataStax is a company that's, flagship product is really Cassandra, is NoSQL, is really proven, used by a lot of enterprise organization. And then the company has expanded out, with this strong kind of data at rest type of capability. We also want to add in data in motion, which is Apache Pulsar, underneath driving, the event stream platform. And then now to also data in use, right? There's also Cascada, the other open source options, and companies moving towards, really like catching up with the times with AI and machine learning towards that direction, and having this strong infrastructure is what we want to introduce you to today. So anyway, so that's me. And then these are just some of the pictorial representation of myself. I'm also a Java champion, also the president of the Chicago Java Users Group, very active in the tech community. Want to encourage everybody to be involved. I believe that, we can make this tech place much better, much more kind of collaborative in some sense, right? So I think it's great. We're building great stuff. And then Also, too, I'm involved, with Pulsar, with Open Liberty previously at IBM, where I was a developer advocate for 3-4 years. I just love my job. I love interacting with folks. So my particular interest area are really mostly, streaming, the event processing, the reactive systems. I've worked also with some IoT MQTT. So, and then you can contact me at any time. These are the different ways of contacting me. And again, I'll share with you towards the end of this presentation. So, okay, so really quickly, kind of go through what I'm be talking about, the agenda. Want to kind of first, talk about computing events, right? There's a lot of confusion too, and there are a lot of, interesting kind of concepts behind this, and it can be confusing as well. And when I talk with folks are talking to me about event storming, event streaming, processing. I mean, how are they different? Let's sort this out first before we get into the API kind of way on how do you interact, with this platform underneath the hood. So bear with me a couple minutes talking about basics, and then also essentially to the kind of use cases that you can leverage on event streaming. And then I'll introduce to you Apache Pulsar, and that's what is powering the DataStax, our cloud platform with all of the event streaming capability. Then I'll share with you too what we have right at DataStax, our Astra streaming, and also some resources. Now, if I have time, because this is a shorter time duration, I've done this presentation with some demos. So if there's time, I'll do a bit of demo. Okay, so let me start. The many facets of computing events. Okay, so let's kind of try to understand first, before we start, what is an event, right? Generically speaking. The thing is, though, I think our minds have been pretty much trained or kind of like tuned to thinking of things in, solving problems in a more kind of, so to speak, simplified way, kind of way of doing things. And think of, if you're a programmer, we're kind of learning things and doing it in a very synchronous fashion. We're kind of breaking things down step by step, right? And that's perfectly okay. It's a great way to learn because, as we know, computing is a very complex process, right? And it involves a lot of kind of, brain power. And also, too, not only that, I think it's artistic in some sense because how you solve problems are very different. How we approach solving problems are so different, right? So let's kind of understand your event first. The thing is, though, what we are trained for, in our mind is not about events. It means just first think of the fact that events, right? We live in an event-driven world. Everything is event. Think of the fact that, even how life begins, right? It's an event. A baby is born. That's an event. Once it happens, you can't turn back in time. It's there. Likewise, in the computing sense, too, an event happened, right? We want to capture that moment. That moment carries with it data. And that's what we're trying to work with. All of the data that's floating around, it means a lot to us, right? So baby is an example. This event, this conference is an event. A rock concert, right? That's an event, a sporting event, all these things, events. So now that we understand the event, that's what we're trying to do, capture all the data, understanding it from a mathematical point of view, a scientific way, from the point of view of relativity. So if you kind of look at relativity, the definition would be is, multidimensional when we talk about events. It can happen in space and time. Again, it's immutable. Once it happens, you can't go back in time. But essentially, if you kind of plot it on a graph, right, that event will change over time. But single event is basically a data point in space and time. It has the XYZ coordinate, right? I think that should be simple enough. We all learned some math, right? The geometry. XYZ is the space, but it doesn't represent everything because it keeps changing. So there's a time element to it. So that makes it very interesting. And that's what we're trying to do in here, event streaming, capturing the change of state of data as it travels through time. Not only that, we're doing it in, real life scenario in which every event can happen at unpredictable times, right? And we're handling asynchronous style of processing, right? Not like everything marching at the same rhythm. That will never happen. So, okay, so that's with a bit of a background. Let's kind of get a bit more into these different terminologies. So if you kind of look at it, right, again, I talk about event streaming, event messaging, event processing, event sourcing, event storming, event-driven architecture. They can mean, different things to different people, maybe, or kind of the level of understanding. So let's try to kind of sort them out in here. I've given a lot of thoughts to this, too. How can we explain, right? So essentially, every event carries with it some data data that can be, very crucial. You want to mine the data from it. And then also a collection of many streams, and that's the challenge too. And sometimes, messaging can drop all of these things. So that's what it is. We need a system that can guarantee delivery of all of these data, these messages, right, from one point to the other. That's the goal. So event messaging, right, if we kind of look into it, is really the basic, the more like, to me, is more primitive sense that we're taking care of data traveling from point A to point B. That's what it is, right? There are many ways of doing it. So we'll look at it in a few seconds. But right now, event messaging is what it is. And then there's also the streaming. Streaming is really dealing with this event. The data points happen in space and time in large quantities too. It's not just one event. We're living in complex times, a million kinds of events happening every single day, right? And not just a million, is kind of an indefinite number of it. That's event streaming. And then there's also the processing part. While we have data, it doesn't make sense if we don't do something to it or extract the information or analyze what it is and figure something out. So that's event processing. And then if you kind of also look into it, right, overall, the architecture is event-driven architecture, an architecture that takes into account the events that are happening in space and time, capturing all of the data, all of these things, notifications, monitoring systems, and fraud detection, for example, things like that. And then there's also event storming, which is actually more of a data domain-driven design kind of approach of analyzing requirements, pulling in all the stakeholders. That's more about requirements gathering, understanding, and kind of brainstorming essentially all of the events that can happen. And then there's also event sourcing, which I won't go into a lot of details because we can spend a couple lectures talking about it. It's very interesting too. It's basically capturing all of these events as they change over time. And that will allow message to replay much more easier than the traditional way of just a database capturing the state of some things, right? Like an order entry, for example, it can change state from, you get the order, new order, and then in process, and then payment, all of these things. Instead of just capturing that single state at any given point in time, we want to do it capturing every single point in time as it changed. So then you can go back to doing message replay, diagnosis, all of these things. So that's event sourcing. Won't get into all the details now. Okay, and then there are also things that I'm highlighting. There are reactive systems, microservices, stateful, stateless, all of these, and then serverless applications. All of these are very relevant to today's world. We are kind of making sense out how we can leverage on event kind of computing way of doing things to kind of implement systems that way. Okay, so let me real quickly, I know that I'm looking at the clock. So event streaming processing, as I talk about, right? Event is each data point in the systems. Stream is an ongoing delivery of these events. And each event happens in space and time. If you think of a cube, kind of a space, events happen. You can't wipe it out. It's there. You can't wipe it. And so basically each event changes, the data kind of happens in point in time, and it changes. So you plot it, that's the stream. So many events together, a collection of them, is streaming data streams. And then complex event processing is essentially not just capturing these, kind of event data, ingesting into the system. It's really the processing part that kind of gives it more value. You analyze the data, derives some kind of insights. For example, I mentioned too about fraud detection system is a prime candidate to use event-driven approach, or event streaming approach, because data keeps coming in. You have many bank account holders, and then you want to make sure that all of their accounts are secure. And so you want to make sure activities are, kind of legitimate. If something is kind of even a slight bit of suspicion, you want to notify the account holders, right? You need to do a lot of analysis. So that's an example of complex event processing. You do event ingestion first and then pass it on. For example, like, we can kind of look at LinkedIn. This, everybody has it. You see that we have newsfeed. We have like our profile, how many people are looking at your profile. Everything is in real time. So basically you want to ingest the data and look at these data in real time. You don't want to wait, for collecting all the data and then analyze it. You want to have data comes in, immediately analyze and give all the feedback and display it on your screen. So like LinkedIn newsfeed. So those are kind of example of complex event processing. And now let's take a look to event-driven messaging. I already kind of talked about it messages traveling from point A to point B. There's an event-driven kind of messaging is basically sender, right? Send the messages, and it doesn't care about who is going to receive it. It's up to those who are interested to subscribe to the message, and then they can receive it. So that's one form of event-driven messaging. And then there's also message-driven, which is basically, think of a queue, right? There's a queue waiting in line. So sender will send the messages to the queue. It has to know where to send the messages to. That queue has an address. So send it to it, and receiver will receive the messages, pick things up from the queue. So once it's picked up, it will be gone. So that's kind of event differences between event-driven and message-driven messaging. And now let's take a look too. Using the event approach isn't the only way. Basically, we live more in a batch processing world. But first, let's take a look at event approach. So you have an event, some data that comes in, you immediately process it, right? I talk about that. It's a very real-time kind of way of doing things. Whereas for batch processing, some data comes in, you just collect them, and maybe at some point in time, you batch them up together and process them. So as you can see, it's slower, but yet some cases too, you may want to use batch processing. For example, employee, kind of information system, those are not urgent. You want to collect all of the changes during the day and process them and during the night, right? So you don't take up valuable computing resources during the day. And now, then take a look too at streaming, and it's getting a bit more into detail is the approach, an architecture approach called PubSub, right? Publish, subscribe. So that describes event-driven kind of messaging. Messages get sent by the publisher, and it's up to the subscriber. If I'm interested in it, I'll subscribe to it. And very often we describe it. For example, Apache Pulsar, Apache Kafka, these are topics, right? Topics identify the messages that it is. And so a subscriber will need to subscribe to the topic in order to receive it when there are messages. And then the broker, you do require this architecture require a broker to be there to actually receive the messages, owns the topic, and deliver the messages accordingly to whoever is subscribing to it. So that's kind of like the basic working. Now, there are many different vendors. They can implement it differently, but essentially this is kind of like the core kind of mechanism of a PubSub type of way of doing things. And you can have multiple producers producing to the same topic or different topics, in a cloud infrastructure, living in multiple cluster, or kind of in the same cluster, but they can be partitioned off in different nodes and servers, things like that. And likewise for the subscriber side. And now there's also message queuing. So queuing too, as you can see, very much like PubSub way of doing things, you decouple the sender and the receiver. However, the way it does it is that you send messages, to a queue. So the queue is kind of known address for the sender to send messages to, and the receiving end receiver will pick up the messages when I need it, and when it is picked up, is removed from the queue. So these are kind of similar kind of purposes, right? Decoupling, very, very high frequency, allowing for high volumes of data being sent from point A to point B. Okay, so now some event streaming use cases, right? Let's kind of take a look. Real-time data applications, right? So it gives better digital experiences. As I mentioned, it's a real-time kind of aspect of this kind of modern day event streaming approach, right? And you don't need to wait. Data comes in, you immediately see the result, pretty much in real time, near real time, I would say. And then, for example, there's also data science, right? In today's world, there are talks here too that talks about AI, machine learning. Those are definitely prime candidates too for leveraging on event streaming, because the data, as it comes in, we want to immediately analyze and then update your AI model, right? The data model, the algorithms too. So you want to have a very fast turnaround. Once you analyze, you update the model and deploy it back into production and so on and so forth. So AI, machine learning, kind of like prime candidate for using event streaming. And then there's also edge computing, for example, IoT. Those are also like, requires like very fast, ingestion of data, and basically too meets the demands of these large volumes of data. And IoT, industrial IoT applications are also prime candidate. Now, this is kind of just an example of an agricultural, just want to kind of pique your interest, kind of, if you haven't thought of it, like how about, some cows, because this is actually a talk I did with a community colleague, right? And then we talk about Kafka and Pulsar, how can we make it kind of work together? But anyway, event streaming can be applied to an agricultural case in which you have cows, roaming the hills. And what if the cow get lost, in an enterprise operation? So you want to maybe attach, some IoT devices to it so you can track the GPS location. And so at the end of the day, you need to gather all the cows back to the barn. And so if you realize something is missing, you can immediately identify it. So it can actually leverage on an event streaming kind of pipeline and know where the cows are too. Okay, so again, kind of like quickly kind of summing up, right? Event streaming can be used in many things. In fact, a lot of things, all things where event streaming is needed, right? So it allows for events, you watch for the events with the system or the application. You only get the data that you're interested in, right? You make decisions in real time and allow for high volumes of messages with very low latency. And then this is just a quick kind of thing to compare to. There are modern day streaming that we're dealing with, and there are also not streaming. It's basically, I can kind of compare with ETL systems, extract, transform, load. And the difference is that, as you can see, they all ingest some data and then process it, right? And then write it to some destination for the modern day streaming. Whereas if it is like ETL systems, normally you involve a database or some sort of file system to store the intermediate data. Now, anytime we deal with any kind of file or database, it incur a cost, right? It's kind of IO, disk IO. So that will incur time to it. So as you can see, the modern day streaming is that I ingest the data quickly, for example, Apache Pulsar, and then let's say I send it down to Apache Flink or Apache Pinot or some other library that can do real-time analysis. Immediately too, you process the data, or even using a Pulsar function within Pulsar, that you can transform the data, you write it out to the sink in memory. It makes it really, really fast. So, okay, now so really quick introduction to Pulsar. Pulsar is an open source project in the Apache Software Foundation, and the many kind of thousands of libraries. And it initially was developed by Yahoo, and they realized they need an event streaming platform that can operate really good in the cloud. And so basically, it's a very much of a cloud native design, right? Cluster based. Also has this concept of multi-tenancy where all your messages are already kind of grouped according to different, tenants, right? The words to use. So you kind of separate out. You can be in the same physical cluster, but logically these messages can be grouped underneath different tenants, right? They are different namespaces, so they don't conflict with one another. And also, too, when you work with Pulsar, you work with the broker. The broker is the kind of quite important, like the centerpiece, right? Managing, receiving all the data, and also dispatching them accordingly. And then in Pulsar's case, you can write, in languages of your choice. You can do Java, you can do Go, you can do Python, you can do C#, right, and .NET too, and other community contributions such as Scala, Haskell, and Rust, and you name it, right? It is there, so you can check that. It's open source, and then also messages are guaranteed delivery as well. So that's another very important aspect of it. And then also I mentioned too about the Pulsar function. So it allows for data being transformed as the data is traveling through the pipeline, and it's very lightweight fashion. And then also one more kind of important thing to it, in addition to other important features, is the tiered storage offloads. So anytime you operate in the cloud, you get charged, if your data is sitting in the primary storage area. Now, some messages can become cold or inactive. So in that case, you might want to move the data to off, kind of like more cold storage, for example, S3 buckets, that cost less, Google file system, something like that. So Pulsar itself too has a native kind of built-in to manage it for you. So then if, over a certain period of time, your message is still sitting there and it's not active, it's basically you can tell, Pulsar to move them off to offload second tier storage that will cost you less. And now, really quick too, what is Pulsar, right? So just want to quickly share with you the number of GitHub stars, the number of contributors, number of, contributors keep rising too. So, and then who else is using Pulsar? So these are just some examples. Yahoo is still using it, and especially Yahoo Japan as well, that we actually DataStax work with, and Verizon. Some of these are, the major vendors out there. And also too, wanting to point out, there's this connectors. You can basically connect with Pulsar too, it works with many different systems. So kind of very flexible, right? You work with many different databases, including here are all the major databases like Cassandra, MariaDB, Oracle, Postgres, you name it, it's there. Messaging systems like Kafka, we also work with them. Language clients, as I mentioned, the client language API bindings are many with all kinds of major languages are there. And then monitoring like Splunk or Datadog, and software as a service like Twitter messaging, Apache Kinesis. And so these are just a few examples. And how is Pulsar different, you may want to ask, right? So as I kind of mentioned about it, there's producer, consumer, you write code to it, you interact with the serverless broker that's running there, very important. And then also, one thing which I wanted to point out is that Pulsar is interesting. Anytime you deal with event streaming platform, you deal with all of these messages. You don't want to lose them, but yet they are also like a laundry baskets of many things. And so you don't want the broker to be slowed down by that. So then, think of them like laundry baskets of clothes, right? So anyway, not to say like that, but the thing is somebody needs to manage it. So basically, the Pulsar has delegated it to Apache Bookkeeper to handle it. As such, Bookkeeper is a very efficient kind of messaging, kind of persistence kind of layer library, and it's very fast, and it segments off all of the messages, so makes it very, very fast, fast read and fast write, and it handles all of it for you. Broker will coordinate with the Bookkeeper. If you need to do message replay, look up some old messages, you can always go through using the reader interface and talk, and then Broker. The reader interface is another set of APIs where you can talk with the Bookkeeper and get all of these messages back. And then also, too, at the present moment, Pulsar is still relying on Zookeeper to help manage things in a cloud environment in which, all of the cluster metadata, the coordination of different, Pulsar clusters is handled by Zookeeper. Okay, so how is it different, right? You may ask. So the thing is that Pulsar internally is basically the internal architecture is very efficient. It's a distributed tiered architecture too. Again, it separates out the compute from the storage, as you can see. Bookkeeper handles all of the log messages, so it's very efficient. And so all of these, right? Stateless Broker is basically handle all of the messages, handling the interaction with producers and consumers. So very kind of convenient, and it solves the problems of bolt-on. Now, if your environment already has Kafka running, has RabbitMQ, some queuing system, basically use Pulsar as kind of like the layer of interacting with the rest of the company too. It's a next generation of enterprise messaging systems, and this kind of show it to you too. And also another feature of Pulsar is its geo-replication. So basically too, it also helps you. You have different regions of in the world that is handling different data center. You can also do replication easily. It's already built in. It's a matter of configuration. You can also do selective message replication, and during kind of when the servers are running too. So you don't need to stop things in order to replicate. Okay, so these are just a couple of developer features. I'll just really quickly running over. We're talking about data pipeline. So how does the API work through, right? The water flowing through the pipeline gets transformed. And it's basically, you can use Pulsar function, that set of APIs you can use for transforming. Let's say, for example, doing a map call, doing filter, all of these are also provided by Pulsar functions. And then this is just an illustration. Is Pulsar function is serverless function platform. You just write it once, deploy it, let the Pulsar infrastructure, the event streaming platform, manage it for you inside this whole infrastructure. Pulsar schema is there to help you if you want to leverage on it to kind of manage your message payload. It supports like primitive data type, key value pair, Avro, JSON, protobuf as well. So very flexible. And there's also this concept of Pulsar I/O. So I talk about the source and the sink kind of connectors. You basically can write your own sink and write your own connectors, I should say. So basically, and as I kind of show it to you, right over here, let's revisit this. You can be connecting with another database or kind of talking with Kafka, for example. It's all there. You can easily connect. And also, too, in terms of API, our Pulsar has this DataStax as a Starlight API, protocol level compatibility for Pulsar layer that can work with, it's on the protocol layer, working with Kafka. You don't need to throw away your old Kafka messaging systems. You don't need to throw away your JMS or RabbitMQ. It's there. Use your API to connect them as well. Okay, so this really quickly, DataStax Managed Cloud. Oh, am I kind of time's up? Yeah, I kind of talked for too long. Sorry. Okay.
The time is up, so if you can just wrap up like 30
Okay.
seconds.
Yeah, I'm almost done too. I was just gonna really quickly just show all of these, the resources too, so folks can kind of take a look at this through my, my slide deck. And I also have a Twitch stream too. I wanted to point out, and with that, there's also Awesome Esther at DataStax if you want to get some example Kafka versus Pulsar, and also, oops, actually, I think I'm not here. Sorry. Okay, and then this is slide deck again. And also, thank you very much. And this is how you can get a hold of me. Thank you. Thank you so much.
Yeah, thank you, Mary. Can you go back to your QR code, at least for people so they can have access to the slide and all the things you couldn't share?
Sure. Okay, thank you.
Perfect. We'll just let a few seconds for people to take it.
Okay, sure.
And thank you very much, Mary. A lot of content, again, a lot of great things to do with Pulsar, but I will let people discover everything about its slide.
Okay. And any questions in particular? No questions.
We didn't have any more time for questions.
Oh, okay. All right. Okay, no problem. All right then. Thank you. Thank you, Betty. Okay, bye-bye.
And so we will have our last speaker for this segment, who will be Anais, about moving beyond APIs, the advantage of ArrowFlight SQL for efficient data retrieval. Hi, Anais.
Hi, thank you so much.
Let's go in again. Let's keep your original time for people who wants to hear the full story of InfluxData, right?
Sure thing. Thank you.
Nice.
Give me 1 second here to get set up. Yeah, I really appreciated Mary's talk. That was very interesting. So today I want to talk about moving beyond traditional APIs like ODBC and JDBC, and really get into the advantages of using ArrowFlight SQL for efficient data retrieval, especially from databases. Just to introduce myself briefly, my name is Anais Dotis-Georgiou, and I'm a developer advocate at InfluxData. For those of you who aren't familiar with developer advocacy, what it is someone who represents the community to the company and vice versa. And so I try to create example repos of how to use our technology with other technology to help get you started, create blog tutorials, give talks like these, and also bring user feedback back to product so we can make sure that we're in alignment with what our customers and users need. And I encourage you to come and connect with me on LinkedIn. So today we're going to be talking about provide some background and give some background around the history of APIs like JDBC and ODBC, talk about why they were created and what they do well as what they don't do well. And then I'll introduce Apache Arrow, because we can't really talk about Apache ArrowFlight SQL without talking about Apache Arrow and understanding how they symbiotically benefit each other. And last but not least, I will finish off by talking about the advantages of Apache ArrowFlight SQL and also share some learning resources so that if you have any more questions around anything regarding this talk or InfluxDB or time series, you have some direction and some places to go to. So before we talk about Apache Arrow and Apache ArrowFlight SQL, and the advantages that it provides for transferring and transporting data between databases or services, I wanted to take a look at the existing APIs to provide some kind of historical context for why ArrowFlight SQL and Arrow were even kind of created to begin with. So ODBC. So ODBC is a standard application programming interface. It's an API for accessing database management systems. It was developed, I think, in the early 1990s. Largely by Microsoft, but by a bunch of different companies. And the goal was to create a DBMS agnostic API for accessing data in a uniform way. It uses SQL as its database access language, and it provides a set functions for function calls, error codes, and data types. And then we saw the emergence of JDBC. So JDBC, Java Development Kit, was introduced in the Java Development Kit in I think the 90s too, quickly after ODBC, And it was largely influenced by ODBC in many ways and can pretty much be viewed as a Javaized version of ODBC. Like ODBC, it allows a developer to write an application that can access a variety of DBMS, but it's specifically designed for Java and is more in line with Java's object-oriented principles. And it was really created to address the need for the standard way that Java interacts with databases. So a little bit more on why JDBC was actually created. The main reasons why it was developed, despite the existence of ODBC, is that it provides a language-specific API. So ODBC is more C-based, which makes it, less than ideal for using with Java since it's object-oriented. And another reason is that it provides platform independence. So this was a key feature of it. Kind of extending this principle of write once and run anywhere. By contrast, ODBC drivers are platform dependent, and this goes against the Java philosophy. Then it also ensures type safety. So it provides compile time type checking, which helps to prevent any errors and enhance code reliability. Another feature is integration with Java features. So it's better at handling exceptions for Java, multi-threading, garbage collection, etc. And then it also has some advanced features like including blobs and different data types, and just has more support. So hopefully we have some understanding now of like ODBC and JDBC and why they were developed and some of the differences between them. And it's important to note too that while I'll be talking about the advantages of ArrowFlight SQL, they still play a really important role in many ecosystems and are still very popular and used in many applications. So now I want to introduce Apache Arrow so that we have a foundation for really understanding Apache ArrowFlight SQL. And in order to understand why Apache Arrow was even created, let's kind of dive into what the world is kind of looking like and the push towards it. So over the past few decades, leveraging big data sets has been an integral part of a lot of businesses' needs because they need to perform a lot of increasingly complex analysis. And so we've seen a lot of advancements in things like query performance, analytics, and data storage. And a lot of these advancements are largely a result of greater access to memory. This greater access to memory is largely in part to things like demand, manufacturing process improvements, and technological advancements. But these lower memory costs have spurred the creation of technologies that support in-memory query processing for OLAP and data warehousing systems or online analytical processing. And so Apache Arrow, what is it? Well, it's a framework for defining an in-memory columnar data that every processing engine can use. And it aims to be the language agnostic standard for columnar memory representation to facilitate interoperability. And there's a bunch of different tools and companies that leverage Apache Arrow. But I think one important note here is that one of the co-creators of Apache Arrow is Wes McKinney, who's also the creator of Pandas. And he was inspired to, create Apache Arrow because he wanted to make Pandas interoperable with all data processing systems. And this is one of the problems that Arrow solves. And so how does Apache Arrow solve some of these problems? Well, it's gained a lot of widespread adoption because it provides really efficient columnar memory exchange. It provides zero copy reads, meaning that the CPU does not copy data from one memory area to a second. And this reduces the requirements for for memory requirements and CPU cycles. Additionally, Arrow has a columnar-based format, And processing and manipulating data is much faster as a result. And I'll talk about this in a little bit specifically within the context of InfluxDB because it's especially applicable to time series data. And what else can it do? Parallel and take advantage of things like single instruction multiple data or SAMD, vector processing, and vector querying. And it also has advantages in that it is a standardization in storage. So like I said, it aims to be the standard data format for databases and languages, and standardizing the data costly serialization and deserialization between systems. So any system that supports Arrow can transfer data between them with little overhead. And this is especially important too when we think about using ArrowFlight SQL to transfer that data. We can leverage Arrow with ArrowFlight SQL, then we reap the benefits of not having to handle the burden of serialization and deserialization. Additionally, Arrow offers multi-language support. It contains libraries that allow you to work with the Arrow columnar format in many languages, including Rust, C++, Sharp, C#, Go, Julia, Python, R, etc. So, all these libraries enable developers to work with Arrow and work with the Arrow format without having to implement the Arrow columnar format themselves. So now let's look at some of the companies and libraries and tools that are using Arrow. So it's really become a building block for a wide range of use cases. Several are in the high performance analytics space, and I just wanted to talk about some of the maybe more famous ones. So first is Apache Spark, and that's a fast general engine for large scale data processing. And Spark uses Apache Arrow to improve performance and conversion between Spark data frames and Panda data frames. We have ClickHouse. ClickHouse is an open source analytical database management system. It uses Arrow for import and export of data, and also for direct querying against external data sets in ArrowStream, Parquet, and ORC formats. Dask is a Python library for parallel and distributed execution of dynamic task graphs, and Dask supports using Pyro for accessing Parquet files. Parquet, also for those of you who don't know, is also an Apache project, and it's a durable disk format that's also columnar as well, and it has extremely high compression and is like 17 times more efficient than like CSV, for example. I believe that's the right figure. MATLAB uses Apache Arrow, again, to support reading and writing Parquet files. Pandas, I talked about that a little bit already, so we kind of don't need to go to that anymore. But for those of you who aren't familiar, it's also a data analysis toolkit for Python, where you can manipulate two-dimensional data structures very easily. It's great. I love it. And then we have Dremio as well. And Dremio is a self-service data platform. It makes it easier for users to share data from any source. And it includes a distributed SQL execution engine. And that engine is based on Apache Arrow as well. Yeah, lots of cool projects that are leveraging Arrow. Another cool project that is leveraging Arrow is InfluxDB. So I work for InfluxData, and InfluxData is the creator of InfluxDB. And InfluxDB is a open source time series database, and a lot more. We also have methods for collecting data and visualizing and analyzing data, but we recently rewrote the entire storage engine in 3.0 to be built entirely upon the Apache ecosystem. And that includes Apache Parquet, Data Fusion, and Arrow and ArrowFlight SQL. And the reason why we chose to write on top of these tools is to achieve certain goals. One was to have no limits on cardinality in our data. And this is because in time series use cases, it's very common that, especially like if we think of an IoT use case where as our project grows and we continuously add maybe more sensors, then our cardinality will grow. And we were finding that there were several users who maybe have, a sort of very high volume throughput, because time series data is generally very high volume of maybe like 800,000 points per second, and they needed their cardinality or the dimensionality of their data to be, 50,000 or 100,000. So we're able to address that problem in part by Apache Arrow because of how efficient the columnar storage is. We also want to provide best-in-class performance on analytics. This is largely due through Data Fusion, which is a query execution engine, but that leverages Arrow, and largely all of the benefits associated with the performance benefits from the columnar database, from the columnar format, are leveraged by Data Fusion, which in turn allows us to have best-in-class analytics. Like, you can't have great analytics if you can't efficiently store your data, right? We wanted also to enable separate compute from storage and tiered data storage, and we achieved this by using Parquet as the columnar disk format and Arrow as the in-memory columnar format. We also wanted to provide operator control over memory usage. You should be able to define things like how you want memory to be used for buffering, caching, and query processing. This is largely achieved through the fact that it's also written on top of Rust, but Arrow contributes to this as well. And then we wanted to also enable bulk data export and import. This will be available through being able to export and import Parquet files directly, but also being able to transfer and transport the Arrow format as well. And last but not least, we wanted to provide really broad ecosystem compatibility, and that's directly associated with the support of Arrow and ArrowFlight SQL. Because, yeah, like we said, any system, it aims to be that standard. So any system that is leveraging it means that we can directly transfer ArrowFlight, Arrow format through ArrowFlight from one system to another. And so this has already provided interoperability with BI tools like Tableau and Power BI and Grafana and Superset, etc. Yeah, so now that I've talked a little bit about ArrowFlight SQL or Apache Arrow, excuse me, and how companies are using it, why it was created, and also how InfluxDB uses it, I want to take some time to introduce Apache ArrowFlight SQL. So Apache ArrowFlight SQL is essentially, sorry, one second. I lost my slides here for a second. Where did they go? Oh, okay, they're there. Sorry. Okay, so ArrowFlight SQL is a client-server protocol that's developed by the Apache Arrow community, and it's used for interacting with SQL databases, and it leverages the Arrow in-memory columnar format, and it uses the Flight RPC framework, which is built on top of the gRPC framework. So what are some of its goals? Its goals are to provide similar functionality to existing APIs like JDBC and ODBC. It does things like execute queries, creates prepared statements, fetches metadata, etc. And it enables clients to communicate with Arrow native databases without any data conversion. So it saves you all of that process of deserialization and serialization, and also having to transpose row data into columnar and stuff like that. So yeah, some of the main components of Apache ArrowFlight SQL is that it is basically two things. It's built on Apache Arrow's columnar format, and Flight RPC, which is built on gRPC. So we're already familiar with Apache Arrow's columnar format. I also want to take a moment here to kind of like emphasize why the columnar format is so performant. And the reason why is because if we think of a traditional table in SQL, where we have a bunch of different columns and rows, if we think about JDBC or ODBC, which converts and stores the rows, works with the data in a row-based format, if you were looking at something like temperature, but then you had a column for location and then a column for pressure, your value types, your types might be like integer, string, float, and they're all different types. Whereas if you represent things in a columnar format, then you are having all of your integer values together. And especially in the case of time series, when let's say we're monitoring a room, the temperature of that room likely is not going to change. So we're going to have several data points in a row for that temperature column that are the same. And so when we store those in a columnar format, not only are we not skipping between types, but we also have the opportunity to enable really cheap compression. And by counting, for example, the number of same values and storing that in metadata. So that's just another reason, kind of briefly, of why the columnar format is so much more efficient and makes so much more sense. And then, Apache Flight ArrowFlight SQL is also built on Flight RPC, and Flight RPC is essentially built on gRPC. gRPC is Google's remote procedure call, and it's a high-performance open source framework that is language agnostic, and it is used for defining service contracts and creates really strongly typed client and server stubs. Some of the features that gRPC provides that traditional APIs do not provide, like JDBC or ODBC, is language interoperability. So gRPC supports a wide variety of languages. You can create services in one language and consume them in the other. In contrast, for example, JDBC is only specific to Java. Network communication. gRPC is designed for low latency, high throughput communication between services over a network. This is not the case for JDBC. JDBC is designed for interacting with the database, not for service-to-service communication. So that's another advantage that you get with ArrowFlight SQL. Protocol buffers or protobufs. gRPC uses protobufs, so does Flight RPC, for defining service contracts and message formats. And that leads to way more efficient serialization compared to typical like JSON or XML. Also, it supports streaming in HTTP2, specifically bidirectional streaming, which allows for more efficient communication. And it really supports real-time data because of this bidirectional streaming. So in other words, like if you need to transfer data in real time or near real time from a database to a client application, the server could keep a stream open and push changes to the client as they occur in the database. And this is especially important for things like time series databases, where having things in real time is critical. Yes. Do I want to say anything else about this? I guess one other thing that's important too about Flight RPC is that it does enable data transport in parallel. It provides parallel transfers, which means basically that you allow data to be streamed from one cluster server simultaneously. And so that just makes it more scalable as well. So now I want to talk about some of the advantages of ArrowFlight SQL. So some of the advantages, high level, is that it's more performant and efficient and language agnostic. We've already talked about some of the performance and benefits and how Arrow in general is more efficient, and also all the languages that are supported. It also eliminates the need to design and implement a new wire protocol. So or wire format. So JDBC and ODBC do not define the wire format themselves. Rather, instead, the specific database driver does. And this is because they are more like specifications or interfaces. They define a standard way to interact with the database, but the actual implementation is up to the database vendor. But Flight already provides a wire protocol out of the box, and so this relieves that burden from the database engineers. It also already provides features like encryption and authentication, and this is largely due to the fact that it's built on top of gRPC, and so that also reduces development effort. And so while standards like JDBC and ODBC have served users really well for decades, they fall short for databases and clients which want to use Apache Arrow or columnar data in general and reap those benefits of columnar data, because row-based APIs like JDBC require transposing the data in that case. And for a database which is in its nature columnar, this means that data has to be transposed twice, once to represent it in rows for the API and once to get it back into columns for the consumer. And so, yeah, you don't have to worry if you are using Arrow and ArrowFlight SQL, then you don't have to worry about any of that. So Flight SQL aims to get rid of a lot of these intermediate steps, essentially. So last but not least, I wanted to talk about some of the resources that you can use to learn more about InfluxDB, time series, Arrow, ArrowFlight SQL, etc. So I encourage you to go to our forums, community.influxdata.com. If you have any questions, I'm usually on there and happy to answer. We also have a Slack page where you can also reach out to developers directly, or I can try and put you in contact with them. The developer advocacy team is myself and 2 other people, and we have Influx community on GitHub, where we contain a wide variety of repos that demonstrate how to use InfluxDB with other projects. There are some really cool demos on there. Most recently, we leverage InfluxDB 3.0 in an example repo highlighting the symbiotic nature between using InfluxDB with OpenTelemetry. So basically, we run this sample application that generates traces, and we use Jaeger and Grafana to visualize them, and also store all of the logs, metrics, and traces within InfluxDB, which is very exciting because InfluxDB historically hasn't handled logs and traces that well, but now it does, thanks in part to Arrow and ArrowFlight SQL. And there's a bunch of other really cool demos and examples on there, so I recommend giving a look. We also have our docs. Our docs are fantastic. I love our docs team. We also have blogs where you can find all sorts of tutorials on how to use InfluxDB, or even more information on Arrow and ArrowFlight SQL. And then we have InfluxDB University, which is a learning management system that we've created where, we leverage one, I should say, rather, where you can go and take classes on all things InfluxDB and earn badges and display them on your LinkedIn, and it's all free. So if that's the style that you like to learn in, then I recommend that you check that out as well. And last but not least, if you want to get started, I think the easiest way to get started with InfluxDB, especially 3.0, is to take advantage of our free cloud offering before you even install anything, just to play around with it, get a feel for it. And if you have more interest in it, then you can look at our other offerings. And so, yeah, that pretty much wraps up everything I wanted to talk about today. Thank you so much.
Thank you very much, Anais. So we reached our 25 minutes, but thank you, which was really insightful and a lot of details, a lot of things, a lot of links. It seems a vibrant, tech community, so it's really great. Thank you very much, Anais, and yeah, looking forward to having you as a speaker in another event.
Likewise, thank you so much.
Thank you. Have a good one.
Bye.
And we will go for a break. We will be back in exactly 40 minutes now, 42 minutes actually. What a great number. So yeah, let's go for this lunch break if you are in Eastern time zone, and see you in 42 minutes. Thank you.